My project is automated coronary calcium scoring using Unet models through semi-supervised learning on non-gated CT scans. Heart disease and heart attack is the leading cause of death worldwide. In the US alone, last year there were around 700,000 deaths due to heart attacks and heart disease. There are two kinds of scans taken in the medical field, the gated and the non-gated CT scans. The gated is known as a specialized CT scan because it's only taken when a doctor or radiologist realizes that the patient may have a heart problem. Otherwise, only non-gated CTs are taken because it can be used for a more variety of things. For this reason, non-gated CT scans are more prevalent in the scan field. This is also why I chose to create a model that could find the calcification and the amount of calcification on the non-gated in comparison to the gated, because it would give a better earlier indicator of how much calcification is in the arteries. I approached this problem by analyzing my dataset and noticed that there was a lot more information on gated CT scans versus non-gated. In fact, the Stanford COCA dataset has real mass segmentations for the gated scans, but only the real scores for the non-gated scans. Training a model to predict scores from a huge 3D volume would cause severe overfitting. So instead, I trained a Unet model to predict and find and segment the calcification in the arteries on gated CT scans using the gated data. I then took this Unet model and predicted on my non-gated images. And at first, it was performing really poorly. It was performing inaccurately and randomly. But this was because the gated and the non-gated CT scans are completely different in terms of how they look to the model. Meaning it's never been trained on non-gated CT scans. So I had to make the non-gated CT scan closely resemble the gated so that it's used to this kind of information. I did this by mathematically deriving these set of equations to try and automatically crop these non-gated scans to look like this. I then re-predicted from my same Unet model trained on gated data, which had a 0.95 dice coefficient on my test set. I then took this model and predicted on these cropped images, and my performance improved 91% on real CAC scores and 23% in classification of buckets. Being able to segment calcification in non-gated CT scans gives an early indicator to the patient of how much risk they are in. And because current medical plans don't cover this cost of being able to search for calcification in non-gated CT scans, it's important that we create a sufficient enough model to be able to predict this information for us.